It is a clear night. You look up. There are, depending on where you live, somewhere between a few hundred and a few thousand stars visible. This is not the actual number of stars. The actual number of stars in our galaxy alone is 200 billion, and there are 2 trillion galaxies. So the real sky is much busier than it looks. Every one of those stars probably has planets. Some of those planets are in the right spot for liquid water. Some of those are probably just sitting there, being a planet, in a perfectly good way. Statistically, we should not be alone. And yet, we have pointed the biggest telescopes humanity has ever built at the sky for 70 years. We have listened for signals. We have sent signals. We have looked for heat signatures, laser pulses, radio chatter, anything, and the universe has said, nothing, which is very strange. And we do not know why. But we have some theories. Some are boring. Some are weird. One of them is the reason certain physicists have trouble sleeping. This is the Fermi Paradox. In simple terms, okay? Let us establish the scale of the problem. Our galaxy, the Milky Way, is 100,000 light-years across. It contains somewhere between 100 and 400 billion stars. Most of them are older than our sun. A lot of them are much, much older. Some of them are 12 billion years old. Our sun is 4.5 billion. That means, if another civilization started on some other planet around one of those older stars, they could have a head start on us of, let us say, a few billion years. A billion years is a lot of years. For context, a billion years ago on Earth, the most advanced life form was pond slime. A civilization a few million years ahead of us would have technology we cannot imagine. A civilization a billion years ahead of us would be, for all practical purposes, a god. And the math says there should be a lot of them, spread across the galaxy. Visible. Detectable. Doing god stuff. In 1950, a physicist named Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. They were casually discussing the possibility of alien civilizations, as physicists do on their lunch break. The conversation moved on to other topics. And then, mid-bite, Fermi apparently just said, "Where is everybody?" "Unsealed." And the table went quiet. Because once you hear that question, you cannot unhear it. The numbers say they should be here, the sky says they are not. Something is wrong. 13 years later, an astronomer named Frank Drake tried to put numbers on it. He wrote down an equation. The Drake equation. It looks complicated, but it is really just a chain of multiplications. Number of stars, times fraction with planets, times fraction habitable, times fraction where life emerges, times fraction where life becomes intelligent, times fraction that builds radios, times how long civilizations last. Multiply it all together, and you get the number of detectable civilizations currently in our galaxy. The problem is, most of the numbers in the equation we do not actually know. You can plug in optimistic values and get 10,000 civilizations. You can plug in pessimistic values and get 0.001. So the equation does not solve the paradox. It just makes the paradox more official. Somewhere in that chain of multiplications, the number is getting crushed to almost nothing. The question is, where? Which variable is the killer? Let us go through the main candidates. Explanation 1. The Great Filter. Some step between rock floating in space and galaxy-spanning civilization is extremely hard. So hard that almost nothing gets past it. Maybe it is the jump from simple to complex cells. Maybe it is the invention of multicellular life. Maybe it is intelligence itself. There are 2 versions of this idea. The comforting one is that the Great Filter is behind us. Something hard already happened on Earth, and we are the lucky ones who got through. The uncomforting one is that the Great Filter is ahead of us. Something hard is coming, and everyone hits it, and nobody survives it. Which is why, weirdly, if we ever find microbes on Mars, that is catastrophic news. Because it means life is common. Which means the filter is not early. Which means it is probably late. Which means it is probably us. Explanation 2. The Rare Earth Hypothesis. Maybe Earth is just extremely lucky. We have a big moon that stabilizes our axis. We have Jupiter vacuuming up asteroids. We have plate tectonics recycling carbon. We are the right distance from a stable, boring star. Maybe most planets never get this lucky, and complex life is genuinely rare. Explanation 3. The Zoo Hypothesis. What if they are out there, they know we are here, and they are just watching, like we watch a nature documentary? The rule is, no contact. Let them develop on their own. See what they do. This is the theory you believe if you want to feel both special and observed. It is also the theory that is hardest to test. Because a sufficiently disciplined zookeeper leaves no evidence. The zoo hypothesis is unfalsifiable. Which makes it bad science, but excellent anxiety. Explanation 4. The Dark Forest. This one comes from a science fiction novel, but physicists take it seriously. The idea is this. Every civilization in the galaxy is a hunter in a dark forest. You cannot know if another hunter is friendly. You cannot know if they will stay friendly. And the cost of being wrong is extinction. So the rational move, for everyone, is to stay silent. Do not reveal your position. Do not answer any signal. The universe is not quiet because it is empty. The universe is quiet because everybody is hiding. And we are over here yelling into the trees. Since 1974, we have sent a handful of deliberate radio messages at nearby stars. The Arecibo message. A map of our location. A picture of a human. This was, depending on who you ask, either a friendly hello or an extremely reckless thing to do with the lights on. Here is the thing. We do not know which explanation is right. We might never know. But the silence itself is data. Every year we listen and hear nothing, certain explanations become more likely. If there were a galactic civilization broadcasting, we would probably have caught them by now. The silence is already telling us something. It is telling us either that intelligent life is astonishingly rare, or that it is common and short-lived, or that it is common and hiding. None of these are comforting. The only cheerful answer would be if we suddenly detected something, and we have not. So the next time you look up at the stars, and you think to yourself, we cannot be alone. Statistically, you are probably right, but practically, on the evidence we have, we kind of are. And that is the Fermi Paradox. In simple terms, if this video gave you a small existential crisis, we have other videos that will do the same thing about different topics. Click any of them. Or do not. The universe is mostly empty either way.